This video will show you how you can calculate the sky background level as well as the limiting magnitude in your image. One of the questions that I often ask is how deep are my images actually going? And the image that you see on the screen right now is actually one that was taken with a 14.5-inch scope, and it's a combination of about 6 hours of exposure time over a period of a couple of nights. And so it looks like there's a fair number of stars there, but how many and how deep they go is another question. Certainly one thing we can do very quickly is we can use the contrast luminosity setting, and we can adjust that to really try to bring out some of those fainter stars, and you can see there's quite a few stars in the background there. So let's back that off. By the way, one of the things that's very helpful to really see how faint things are is just to flip the reverse image on, and then you'll often see a better view that shows you the highlights of the small stars and fainter stars that are visible there. So let's get rid of that. And then now let's take the analysis function. And the first thing we'll do is we'll plate solve this image. And we've got the rough image center. We know the focal length of the scope and the pixel size. We're going to use the UCAC4 catalog. The other parameters are pretty much default, and I'm not going to hide the computation form, so I'll have some control over that, and away it goes. So it will go and it'll extract the stars that it can find in the image, and then it'll come back and say, hey, I've got 87 stars that I think I can match up and give me a maximum polynomial degree, and the higher the polynomial degree, chances are the better the fit. But for our purposes, we really just need to go to, say, third order computation, and we can compute that, and we can get a distribution of stars. This diagram will illustrate some field curvature, and that's really what it's showing here. It's multiplying the distortion in the image by a factor of 30, so it's not really nearly as bad as it shows. But now that we've plate solved it, we've got the center coordinates, and you can see where it's actually mapped out the stars it's found along with the residuals associated with them, and the residuals are pretty small in most cases. The higher residuals here of 1 arc second or 0.2 are not really any concern that we have. So we'll go up to image display and we'll refresh the image, and that just gets rid of the nomenclature we had on it. Next we'll go to analysis and we'll go to photometry, and we'll do an automatic calibration of this image. And so again, same kind of parameters that we've got, same reference catalog, and we'll go ahead and let that operate. And this is going to take a little bit of time because it's going to have to go through those stars and try to match up a number of stars with known values in the catalog, which is what it's done here. And we can say OK to that, and it now shows us on the image all the different stars that it matched up and what their relative magnitude is. So we'll say OK to that. And again, once again, go back to image display and just clean off the image by hitting image refresh. And next we'll go to analysis, photometry. We'll say, OK, go ahead and find the position and extract all the stars. And this will take about a minute to do. It's going to go and look in detail at every single stellar object that it can find on that particular image. And there are quite a few. I think it's on the order of about 10,000 stars. And now it's come back, and sure enough, it's found a lot of stars. And it's not done processing yet, and it's going to give us some graphs. And one of the things you'll notice is the screen gets very crowded here. And this is a very small screen, which I deliberately selected in order to allow us to use this on just about any laptop for the purposes of viewing the videos. Let's go down and we'll scroll right down through this list. And it found about 6,700 stars. And the background level is 21.25 magnitude per arc second. And that's a very nice dark sky, and this was taken from Chile with a very good sky conditions, and so this will give you an estimate. If you're familiar with the sky quality meter that's sold that does a similar kind of function, you can actually get this directly off of Prism. It will give it to you instead. So we'll say OK to that, And over here we'll take a look at some of the graphs that it's produced. And here what it's showing on this first graph is it's showing the distribution of stars all the way down to the level where it's getting a signal to noise ratio of 3. And 3 is generally considered the minimum detectable level. In fact, when you've got multiple images like we do with asteroid detection, we go down to about 2.2. But for our purposes, this is preset to 3. So that's showing you all the stars that are being detected. And you can see that we're starting to get stars all the way out to 24th magnitude. So we'll say goodbye to that one. This one shows you the distribution of stars with respect to their full width half max. And it can be a bit misleading. I don't find this chart very, very useful. So we'll skip that one for now. And let's take a look at this one, which is a much more interesting chart, because it shows you the number of stars that are found per magnitude. And there's a NASA publication which basically tells you how many stars should be found in each of these sections between 22nd, 23rd, and so forth. And if we use that formula that NASA provides, we should be having at 23rd magnitude something like about 900 stars compared to the 500 here. We're not getting that. We're only getting about 200 stars. So what we can say is that our real limiting magnitude is around 22.2 magnitude, because that's where we're getting effectively pretty much all the stars that are available in the sky. The good news is that even at 23rd magnitude, we're probably getting about 20%. Now down to 24th magnitude, maybe we're getting about 1 or 2% of the stars that are available, but it's still not a bad result for what we're doing. On the actual image itself, we can zoom in on any star, and it will show you the magnitude of the stars. So there's a 19th magnitude. And in order to really highlight this, we really need to bring up the contrast on the image. And so there, as we start to bring up the contrast, you start to get a much better feel. And again, we'll flip it around to do that. And again, nice thing with Prism, you can just move it around with your hands. So there's a 22nd magnitude star that it's picked up there, 21.7 magnitude star there. And so you can see it does a very thorough job of assessing the magnitude of all the stars. So what we've learned here is how to basically go in and take a look at, after plate solving the image and photometrically calibrating the image, we can now calculate what is our background sky level, how good is that, how much light pollution do we have in effect, and at the same time, what's the limiting magnitude of our CCD camera combination as a result of combining images on these multiple exposures.